Section 14C, question number 1. This question asks us to use investigation 2 in the section in order to help us solve the opening problem on page 344. So in the opening problem, there is a base jumping competition, and the function of the base jumpers is f of t equals 452 minus 4.8 t squared. So when I substitute in various values of t, I will get the height of the jumpers in meters above the ground. So if I use this calculator here, I've already put in the function when t equals 0, and obviously the height is going to be 452 meters. I'll go back here and I will change the time to 1 second to get 447, sorry, just trying to squeeze that in, 447.2 meters. And then if I go back in here again and change this again to 2 seconds, which is 432.8 meters. And then again, I will edit this to be 3 seconds and see it's 408.8 meters. Okay, so once I do that, I can find the gradient between various points here. So the gradient is the 1 y value minus the original y value over the first time minus the original time of 0, and then when I do that calculation I get negative 4.8 meters per second. When I find the next gradient from when time equals 2 seconds compared to time equals 0 seconds, I see it's 432.8 meters minus the original 452 meters. 2 minus 0 seconds gives us negative 9.6 meters per second. So speed is obviously increasing here. And then one more time, the distance of the height of 408.8 meters, subtract the original 452 meters all over a time of 3 seconds, gives us negative 14.4 meters per second. So we obviously see that the base jumper's speed is increasing as time passes. So in the investigation, we were looking at a curve and we're bringing one point closer to the other, and then we're evaluating the gradients at different times. And so when we do this, I'm going to look in the question it asks us to find the speed of the jumper for when time equals 0, time equals 1, time equals 2, and time equals 3 seconds. So obviously when time equals 0 seconds, he's not moving yet. So I'm going to skip over 1 and go right to time equals 2. We just follow the same process that we used in the investigation. And so I'm going to use point A as 2 and 432.8, and so that will be the constant point that I'm going to leave stationary. And then point B, I'm going to look first of all when time equals 3 seconds, then the height is 408.8 meters. And I'm going to bring the point closer and closer to that time of 2 seconds for a constant point, and then I'll bring it to 2.1 seconds, 2.01, 2.001. I'll go a little bit closer than is requested, and then we'll be able to see what's happening to the height above the ground. As we go along the curve, we bring that point down closer and closer to the 2 second point, and then we'll find all the gradients along the way. Okay, so I filled in some of the values here. When we substitute 2.5 into the function, we see we have a value of 422 meters. When I substitute 2.1 into the function, I get 430.832. I'm going to include lots of decimal places because I think I need a lot more accuracy. When I substitute 2.01 in, I'm going to get 432.60752. And then when I substitute in 2.001, I'm going to get 432.7808. And then when I find the gradient of the chord AB, so the gradient between these 2 points, as I calculated up here earlier, I'm going to get, first of all, negative 24, that's meters per second. Then I get negative 21.6 meters per second, then negative 19.68, negative 19.25, negative 19.2. Okay, so notice that the gradient is getting less and less steep as we investigate, or we bring the point from 3 seconds closer and closer to 2 seconds, thus bringing the 2 points A and B closer and closer together. So I will then, so that's kind of bringing the point from the 3 second mark towards the 2 second mark, which would be from the right. And then if we look at the next point, I'm going to then start from the left and move up towards 2 from the left. So I'm going to start at 1 second and get a height of 447.2 meters, then 1.5 seconds, and I calculate 441.2 meters, and then 1.9 seconds, the height is 334.672, 1.99 seconds, 432.9915, and 1.999 seconds gives me a height of 432.8195. And then again, I'll find the gradient of the chord AB, and the first gradient is negative 14.4 meters per second, then negative 16.8 meters per second. The next gradient would be negative 18.72 meters per second, then negative 19.15, negative 19.195. So we see that as the point gets closer and closer, moving from the left up to the right, from 1 second up to 2 seconds gradually, we see that the gradient is getting more and more steep, from negative 14.4 up to negative 19.195. Notice that when we move from 3 seconds down to 2 seconds, thus bringing point B closer to point A from the right, that the gradient is kind of zeroing in on negative 19 area. And when I bring point B from the left up to the right, from 1 second up to closer to 2 seconds, we see that the gradient gets steeper and steeper up to negative 19.195, zeroing in on what appears to be negative 19.2. So we see that these two values, if we went even further, 1.9999 or 2.0001, we would see, I think, probably a closer value to negative 19.2 for the gradient. So I can conclude, therefore, that at time equals 2 seconds, the jumper's speed is 19.2 meters per second downward, being because it's negative.